Hi, my name is Sarah Chisnell. I'm the staff scientist here on the 3rd floor at Science North in the Discovery Theatre. This year is the International Year of Chemistry, and as such we've been celebrating it every month, which brings us to thermodynamics. Thermodynamics is a term that refers to the heat of reaction. So some reactions gain heat while others lose heat. And we see this in all kinds of different chemical reactions, but we actually use them quite often. So if you're familiar with one of these, an instant cold pack, this is a chemical reaction that is endothermic. It uses up the heat so it feels cold. This, I'm not sure if everybody's familiar with them, but these are heat packs. So chemical reversible heat packs. What happens is in here you have a chemical reaction that actually gives off heat while it's reacting, and these things stay hot for about 45 minutes or so. Now, these instant cold packs are not reusable. As soon as you use them once the cold is gone, they're gone. The heat packs, however, are reusable, just because we're able to reverse that chemical reaction. So the first one we're going to look at is the instant cold pack. A lot of people wonder what's in here, right? There's some sound, it jiggles around kind of like sand, and you have to break whatever's inside in order for the chemical reaction to happen. So what we're going to do is we're going to cut this open and give you a little bit of a glimpse inside. Okay, so inside we have a baggie. This is the thing that you pop, and this is just water. All that is water. And we have these little white beads. So if you take a look at this. Now typically these are going to be ammonium nitrate, which when mixed up with water takes away heat. It uses up heat for that chemical reaction to proceed. So we'll just cut this baggie of water open, pour it in. Okay. And we're going to give it a little stir. Now, if you can see, it just looks like those white beads are floating around in the water. But a chemical reaction is taking place. It's just very slow. Eventually this will become like a slurry or a gel kind of thing when all of that ammonium nitrate is dissolved. But for now, when you put the thermometer inside, the temperature drops very rapidly. It'll drop to a certain point and stay at that point for, you know, about an hour or so typically of these heat packs, or of these cold packs rather. So we'll just let that sit off to the side, and in a few hours you'll get to see what the slurry looks like. On the other hand, we are going to take a look at these instant heat packs. Alright, so we're going to cut this open now and see what's going on with this solution. I'm just going to attempt to pour this into this little beaker here. Okay. So in this bag here, the inside is really smooth. The solution is really good. Out here, there's dust, the atmosphere can get to it. There's already a little bit of crystals around the top of the beaker. So this one, as soon as it cools, it'll crystallize, especially if you just bang on the table or scratch the glass or whatever. This one, however, they have to put these metal disc initiators into the bags. And that's because the crystal growth can start from here, but you have to pop that thing. You have to kind of snap it back so that there's a little shock. The crystals grow in the little grooves that are there, and then it just propagates throughout the solution. As soon as you have one crystal to start with, the whole solution can crystallize if it's at room temperature. In here, you eliminate any chance of any kind of crystal growth other than on this little disc because it's a closed system. Out here, most anything can start this crystal growth. So a little bit more controlled inside of these bags, and that's why these reusable heat packs work quite so well. So I hope that gives you a little bit of information about thermodynamics and the chemistry involved with releasing heat or using up heat during reactions. The next web post will be about reversible chemical reactions.